Hello class, let's continue with this lesson 5 from topic number 3, which is, as you may remember, the solution to a system of equations in two variables. I forgot something in here. System of two equations. Two equations in two variables, okay? Don't forget that. We're only gonna study this type of system. Two equations in two variables. Are there any other types of systems? Yes, you can have systems of more equations, 3 equations, 4 equations, and more variables. Okay, 3 variables, 4 variables, etc. But only at least in this semester we're gonna look at this type of systems. Okay, and if you remember also, I also told you about one method to solve these types of systems, and that method was known as substitution method. Now we're gonna look at the elimination method, also known as the addition and subtraction method. Okay, so let's first create a little story over here. Let's suppose that you go to a fair, guys, and as you know, in those fairs you have these types of attractions. Okay, let's consider this one. Okay, so you're one of these people right here, and let's suppose that you face the next situation. You want to know how much they charge per adult and per kid, because this attraction has different prices, one for adult, one for kid. And let's suppose that you want to find that in a sort of mathematical way. I mean, of course you can just go and ask, but that's not the point. Okay, let's suppose this. Let's suppose the following. You know the following information somehow. Let me, I don't know what's happening over here. Wow, forget about it. Okay, so what you know is this. Okay, in that certain game, I think it was one of those things that just goes around many times. What you know is this. They have different prices for adults and for kids. And what you know is that over a period of 1 hour, you observe from the distance that 10 adults go, okay? 10 adults go to the attraction and 6 kids. Okay, this is what you observe over 1 hour. Let's suppose that you're here just sitting down on a bench very comfortably, and you observe that. Okay, the number of adults that go in here and the number of kids is 10 adults and 6 kids. And then you know somehow that the owner of this attraction over this period of time, over 1 hour, makes $45 in total. Okay, due to these 10 adults and these 6 kids. Okay, perfect. That's the first piece of information that you know. And then over the next period of time, over the next hour, you observe something similar. You observe now that 11 adults go into the attraction and 8 kids. And then also you get the information that over this next hour, the owner made $53. Okay, this is what you know. This is the information you know. You may call this piece of information number 1 and piece of information number 2. Perfect. So this is the facts that you know. And remember, what do we need to know? We want to find out the following. I'm going to represent by letter A, or by the variable A, the price of an adult ticket to enter into the attraction. And I'm going to represent by K the price of a kid ticket. Okay, that's what we want to know, and I'm declaring as always my variables from the start. Okay, what do we do to find these two variables? Okay, let's see. Can I create some equations or something in order to arrive at the solution? Yes, that's right. We can. In what way? Let's see. Okay, so first I'm gonna write this, and you're gonna understand what it means right away. So I'm gonna write this equation. You see? And what does this mean? What does this mean? It means the following. In the first hour that relates to this piece of information, I know that 10 adults went into the game and 6 kids, and each of those adults paid this amount price, this price, okay, the price of an adult ticket, and each of the kids paid this price, which is the price of a kid ticket. And so this is what the all of this expression 10a is the amount of money that the owner recollected due to adults, and all of this represents the amount of money that the owner recollected due to kids. And all of that amount of money, when you add those together, he's gonna get $45. Okay, that's what we know. And so I can construct this equation with my information and with my two variables that I declared. And very similarly, I can create the next equation, which is going to be 11 adults paying a money, amount of money, plus 8 kids, each paying k amount of money, will be equal to $53. There you go. And as you can see here, we have a system of two equations in two variables, which are a and k. Now you maybe often will see me that I draw these two braces like enclosing my two equations, and sometimes mathematicians do this. Sometimes in order to kind of like say that these two equations are simultaneous, or that they are like they are related to one another, they pertain to the same problem. Okay, these equations are not to be taken independently, they are related through a system of two equations in two variables. Okay, so now we're going to apply this other method, guys, the elimination method, in order to find a and k. In what does this method consist? What is it about? Okay, it's the following. We're going to write step 1. You're going to do the following. You're going to choose a variable to eliminate. Okay, what variable? And it doesn't matter. It doesn't matter. You have two variables, a and k. Choose one. It doesn't make any difference which one. So I'm going to choose k. I choose k. Okay, I'm going to eliminate this variable. How? Second step. What you will do is this. If you observe, the variable in the two equations has a coefficient, right? In this case, the variable has a coefficient of 6. This expression has a coefficient of 6. And this other expression with k, your variable that you want to eliminate, has a coefficient of 8. Well, what you need to do in the second step is this. You're going to multiply the first equation, this one, by the coefficient of the variable in the second equation. Remember, these are your coefficients, 6 and 8, the coefficients of your variable that you chose. Okay, the first equation, you're going to multiply it by the coefficient of the k in the other equation. What does that look like? It looks like this. I'm going to multiply the left side by 8 and also the right side by 8. And this is what it means to multiply an equation by a certain number. What that means is that you're going to multiply both sides. Whenever you hear the expression, multiply the equation by whatever, what that means is multiply both sides by that whatever, which is what I'm doing right now. Okay, And the next thing that you have to do is now multiply the other equation, this one, by the negative of this coefficient, by the negative of this coefficient. So I'm gonna write this left side, as you can see, and I'm gonna multiply it by the negative of 6, which is minus 6, and I'm gonna do the same in the other side. So we have 53, and I'm gonna multiply it by minus 6. So this is what I'm gonna do. So step number 3, I'm gonna, in the second step, I just expressed what I'm about to do. And in the third step, I'm gonna actually do it. So let's do it. 8 times this and 45 times this, etc. Okay, so I'm just gonna do it rather quickly and without any explanation. This is very simple. 45 times 8, that's going to be equal to 360. Remember, you can always use a calculator, no problem. And now the other equation will be this. Okay, this is what you get. I just performed the multiplications that I established in the second step. There you go. Okay, next step, step number 4. Okay, once you have done this, you will notice that look at your expressions with k in both equations. You have in here 48k, and you have in here minus 48k. So it's basically the same expression, the same term, but of opposite sign. And the core of this method, or the real trick, is this. What you're gonna do next is add both equations. Add both equations, this one and this one. By the way, I maybe, like I always tell you, we need to label them. We're gonna add both equations side by side. What does that mean? It means the following. I'm gonna need to erase this, and I'm gonna continue in the left side. That's not a good way to do things, but well, I need to do it because I ran out of space. But you always remember, you always work from top to bottom and from left to right as possible, as much as possible. Okay, what that means is this, guys. You're gonna add this side with this side. Okay, like I'm gonna copy the whole thing in here. 88 plus 48k equals 360. This is my first equation. And then we have minus 66a minus 48k equals minus 318. So I just copied whatever all I had. And you're gonna perform now the step number 4, which is add both equations side by side. And a usual way to do this is the following. You're gonna draw a horizontal line over here, and you're gonna perform the addition. You're gonna perform the addition of this, all of this, plus all of this, and you're gonna put it right here. You're gonna drop down the equal sign, and you're gonna perform the addition of this plus this, and you're gonna put it right here. So let's do it. When you add all of this side, all of this left side, with all of this left side, what you're gonna find is that the 48k and then the minus 48k will cancel one another. You see? So basically what's going to happen is that you will only have to add 80a plus minus 66a. So let's do it. 80a minus 66a is basically subtraction, and you will get 14a. And usually since these two are canceled, we can write this. Okay, so this is like 0. When I mean, I could write plus 0, but I don't have to, right? It's 0. And then on the right side, we have 360 plus minus 318. And that's going to be, according to my calculator, that's going to be 42. And look at this, guys. We have by doing this trick of adding both equations side by side, what we can see, what we have discovered is that we end up with an equation. Maybe let me write this down in a more compact way because it looks too far away. 14a equals 42, and you can see that we have found an equation with just one variable, which you can solve. Okay, how do we solve it? We just divide both sides over 14, and there you go. You get 3. A equals 3. We have found one of our variables. And remember, once we have found one of our variables, finding the other one is very simple. All you have to do is stick this value or plug it in any other equation. It doesn't make any difference. You can put it right in this equation. You can put it right there. Okay? You can put it right here. You can put it anywhere. It doesn't matter. So let's see. Let's put it right here on this first equation. One more time. Let me erase all of this. Okay, and step number 5, plug the value of the of the of the variable found in any other equation to find the remaining variable. Okay, so I'm gonna put it right there. And here we go. We have 10a, but a is 3. I just found out. Plus 6k equals 45. And the rest is very easy, right? 10 times 3, that's 30, plus 6k equals 45. And then we have 6k equals 45 minus 30. We have 15, right? And finally, k will be equal to 15 over 6. How much is that in decimals? We have 2.5. K equals 2.5. And that's my other variable. So what can I conclude? I can conclude that, remember, what was A and what was K? A was the price of an adult ticket, and K was the price of a kid ticket. So basically my conclusion is this. Conclusion: adults pay $3 for the attraction and kids pay $2.50. That's it. This is my conclusion and I'm done. So that's how this works, guys. This other method of elimination. It works by choosing well, all of these steps, okay, 1, 2, 3, 4, and 5. Basically it involves the multiplication of the two original equations by some integers or some coefficients. It doesn't have to be an integer. In this case, my coefficients are integers. That's not always going to be the case, and it works in that way. You multiply the first. Let me raise this to braces, and I'm gonna do that in blue. Maybe it's gonna be more. It's gonna highlight what we're doing. So if you want to eliminate k from these equations, okay, look at their coefficients. This one has 6, this one has 8. Multiply this equation, all of it, by 8, which is the coefficient of the other equation on the k, and multiply this equation by the negative of the other coefficient, which is 6, by the negative. By doing so, you will always be able to produce this trick. The trick that when you do this whole thing, these multiplications and so on, and when you go to the step number 4, which is the most important step, add both equations side by side, you will always be able to eliminate, like we did here. To eliminate one of the variables, in order to find one of them. And that's basically how it works. Now, if you were wondering whether you can do, for example, instead of 8 and minus 6, what about minus 8? Multiply this one by minus 8 and this one by 6. You know that the negative with this one, that is perfectly okay. Perfectly okay, no problem. That is also perfectly valid. Okay, so that's how it works, guys. Maybe in the next class, I'm going to give you another example of this, of the two methods, okay? One of substitution method and one of elimination method, and that's about it, okay? Okay, guys, so that's it for today, and thank you so much.